Okay guys, welcome to our channel Row and Basic. So in this video, we will learn on how to solve your exponential inequalities. So first, let us define the properties of an exponential inequality. So on the board, we have two properties, two premises of our property. So first is for this one. If b is greater than 1, then the exponential function y equals to b raised to x. So let us not forget that our b is our base and b is greater than 1. So it means we are dealing with b greater than 1. So I know you are all familiar with numbers that are greater than 1, of course. So if b is greater than 1 is increasing for all x, this means that b raised to x is less than b raised to y if and only if x is less than y. Okay? Then we have if b is greater than 0 but less than 1, then the exponential function y equals to b raised to x is decreasing for all x. This means that b raised to x is greater than b raised to y if and only if x is less than y. So if you can see the inequality symbol in here and the inequality symbol in here. Okay? So the inequality symbol is retained. On this one, the inequality symbol is reversed. Okay? So I will give you an example of y equals to b raised to x, where b is greater than y, so it can be y is equal to 2 raised to x, because our exponential function defines it as y is equal to b raised to x, where b is greater than 1 and should not be equal to 1. Okay? So we have y is equals to 2 raised to x, so it can be 5 raised to x, or as long as your base is greater than 1. So it means that the trend is increasing. Another premise of your property, we have b is greater than 0, but, so I will discuss it, or let us understand this property using a number line. So the numbers between 0 and 1 are, of course, at the middle we have 1/2, 1/4, 3/4. It can be fraction or decimals. Okay? So it means on this premise of our property, where the trend is decreasing, the base or the basis can be a fraction. So we have this one. Y is equal to 1/2 raised to x, or shall we put parenthesis, or it can be y is equal to 2/3 raised to x. So as long as the fraction is less than 1 but greater than 0. Okay? So this example. So as y equals to 3/2 raised to x belongs to this property, or on this one. So it does not belong because 3/2 is greater than 1. So 3/2 is 1 1/2. Okay? So we will be dealing with fractions that are less than 1 but greater than 0. Okay? So let us use this property in solving your exponential inequality. Okay, so on the board, we have here two examples of exponential inequalities, and we have to solve for the value of x. So if you will try to watch the other video about exponential equations, we are solving for the value of x. And on this one, we will be solving for the value of x, but we are concerned with what we call your solution set. Okay? Okay, so first example, we have b is greater than 1, and the second example is b is greater than 0 but less than 1. Or if you can see, the basis or the base of your exponential inequality are in fraction form. So now let us first solve for number 1. So number 1, we have 3 raised to x is less than 9 raised to x minus 2. Okay, so just like solving your exponential equations, we will be using your one-to-one property. That means that we will rewrite your exponential expression on both sides of your inequality. Make the bases the same or make the base equal. Okay, so we have the base 3 in here, then we have 9. Of course, we can make 9 an exponential form with base 3, or shall we say 3 squared is equal to 9. Okay, following? So 3 squared is equal to 9. Then copy the exponent, x minus 2. And we copy the exponent of 3 in here, which is x. Okay? Using the power rule or power raised to another power. And after making the bases or the base equal or the same, we will disregard the base and just copy the exponents. So copying x, then we have 2 using the power rule or exponent raised to another exponent. So we should multiply 2 to x minus 2. Okay? Simplifying, we have x is less than, here we have 2 times x, so we have 2x. Then we have 2 times negative 2, so we have negative 4. Okay? Then simplifying, we have, so combined like terms, we have 2x. So let's be clear in here. So we have 2x, then minus 2x, then minus x. So where did we get minus x? So here. So to eliminate x on the other side, we have minus x. So therefore, we have to subtract x on the other side. So we have 2x minus x, and x on the other side will be eliminated. And we have to transfer 4 on the other side, or we have to eliminate minus 4 in here. We have to add 4. And of course, we have to add 4 on the other side. So we have 4 is less than 2x minus x. So I guess we are clear in that. Okay? So just like the transposition. But again, transposition is not an operation in solving your inequalities and equation. So we have 2x minus x is x, and bring down 4. So we have 4 is less than x, or shall we write it as x is greater than 4? Okay? X is greater than 4, or 4 is less than x. So they are the same. Just follow the opening and where your inequality symbol points. So it opens on x and points on 4. So if we will try to rewrite it, where x comes first, so x, then the opening is still on your x and it points on 4. Okay? So we have x is greater than 4, or it can be written as 4 is less than x. Or if we will try to read it from x, x is greater than 4. Okay? So the opening of your inequality symbol denotes the higher value. So it opens on x and points on 4. Okay? So using your set builder relation, or this one, we can write your solution set as x is an element of real number such that x, just copy this one, is greater than 4. Okay? X is greater than 4. If we will try to put it on a number line for you to understand it more, example, we have 0, -1, -2, and so on. Then we have 1, 2, 3, 4, 5, 6, and 7. So greater than 4, the circle is open. And that's it. From 4 until positive infinity. Okay? Where 4 is not included. Okay? So now let us proceed to number 2. So using this one is enough. So x is an element of real number where x is greater than 4. Okay? Now let us proceed to example number 2 where b is greater than 0 but less than 1. Okay. So we have 1/10 raised to x plus 5 is greater than or equal to 1/100 raised to 3x. So again, let us rewrite your basis or your base on make it the same or equal using your one-to-one property. So we must follow always the lesser base between 1/10 and 1/100. Of course, we will follow 1/10. Right? And because it's already 1/10 in here, so we will just have to copy its exponent and 1/10. Okay? Next, we have 1/10. How can we get to 1/100 from 1/10? Of course, we will square your 1 squared is 1, 10 squared is 100. Just like that. And copy the exponent 3/x, or simplifying, we will have this one. Okay? The exponent 2 and 2 in the denominator is just like 2 in here. 1/10 quantity raised to 2 is 1 squared over 10 squared. Okay? The exponent of a fraction is distributed to the numerator and the denominator. Then copying. Okay? So let us not forget the exponent in here. So we have either put a parenthesis in here, then 3x, or you can use your bracket, or to make it easy, it's just like 1/10 raised to 2 raised to 3x. So we are on the same basis now, or we have the same base of our exponential inequalities. Now let us proceed. Let us simplify. Okay? So because we have now the same basis, so we will disregard the base and copy the exponent. Just like that one. And the property that we have discussed previously will now be used. So look at the sign. So we have x plus 5 is greater equal to 2 times 3x. Now we will proceed to this one. The inequality symbol will be reversed. Okay? On this one, if you can see, the inequality symbol is retained. Again, and here, because of this one, when we are dealing with a fraction less than 1 but greater than 0, the inequality symbol will be reversed. And if we are dealing with the base which are greater than 1, the inequality symbol will be retained. Okay? Okay, let us continue. So we have x plus 5 is less than 6x. So again, that inequality symbol is reversed. Okay, simplifying, we have (6x minus x). So the positive x in here will be transferred and it will become negative x using the subtraction property of inequality. So eliminate x on the other side, minus x, minus x. So we have 6x minus x. X will be eliminated on the other side. The remaining will be 5. Okay? Continuing, we have our symbol. 6x minus x is, of course, we have 5x. And on the other side, we have 5. Then dividing both sides by 5 to eliminate 5 and to isolate x. Sorry, we have 5 divided by 5 is 1. So now we have 1 is less than or equal to x, or the proper way of writing it, x is, again, the opening should be on x. Or writing it using this one, we have x is an element of a real number such that x is greater than or equal to 1. Okay, I guess that we are clear on both examples. Again, using the property, when we are dealing with the basis or whole numbers, mostly greater than 1, the inequality symbol will remain or retain. Okay? And when we are dealing with the bases that are greater than 0 but less than 1, and they will be fractions and decimals, your inequality symbol, just like in here, will be reversed. Okay? So I guess we are clear on that. Let's proceed to another example. In our next example, we have 4 over 6 raised to x is greater than or equal to 36 over 16. So by following again the property or the one-to-one property of exponential functions, we will put or write your exponential expression, both sides of your inequality with the same basis. So we have 4 over 6. Okay? And this one will become 4 over 6. So are you following? So writing the exponent x, of course, 6 squared is 36 and 16 is 4 squared. Okay? Or, simplifying, we have this one. 6 over 4 squared. Okay? So, are the bases equal? We have 4 over 6 in here and we have 6 over 4 in here. Okay, so I will give you this one. So we have 4 over 6 raised to x, and we have 4 over 6 raised to, we have negative 2. Okay? Or this one. From 6 over 4, the exponent is negative 1. Sorry, we have positive 1 and positive 1. 6, we will bring 6 to the denominator and the exponent will become negative 1. And 4, we will bring 4 raised to 1 on your numerator and it will become 4 raised to negative 1. Or shall we say we have 4 over 6 raised to negative 1 and we have 2 in here, so we have times 2. So we have 4 raised to 6 raised to negative 2. Okay? So that is how we simplify this thing. Or I will give you another example. This one. So we have example 2x raised to 3. If we will put x cubed on the denominator, it will become negative and 2 will remain on your numerator. Okay? And we have example this one. We have 2 raised to x squared. If we will try to put x squared on the numerator, it will become 2 raised to 2x raised to negative 2. Okay? Another one, we have 3 over x raised to negative 2. If we will try to put this denominator x raised to negative 2 on the numerator, it will become 3x raised to 2. Okay? So the sign will change if we will try to, the sign of the exponent will change when we are bringing it to the numerator or the denominator. Okay, so I guess that it is clear in here. So let us continue your example. So I will rewrite it as, to make it more clear. From here, 4 has an exponent of 1. So it was transferred in the numerator. So that will be 4 raised to negative 1. And 6 on the numerator is transferred in the denominator. So that is 6 raised to negative 1 and the exponent outside is 2. So copying, we have 4 over 6 raised to x is greater than or equal to 4 over 6 raised to negative 1. This one, distribute 4 raised to negative 1, 6 raised to negative 1, and we have 2 outside. Okay? So I guess we are clear. Then simplifying, we have, so if you can see, we have now the same basis. And we are dealing with fractions. So 4 over 6 is less than 1 but greater than 0. So since b is greater than 0 but less than 1, again, since b is greater than 0 but less than 1, the sign will be reversed. Okay? So the sign or the inequality symbol will be reversed. So from greater than, it will become less than. Then disregard the basis and copy the exponent. X is equal to negative 1 times 2. So we have x is less than or equal to negative 2. So we have now your solution set, or it can be written as x is an element of real number such that x is less than or equal to negative 2. So I guess we are clear on this example. Let us proceed to another example. We have 5 raised to x is greater than 125 raised to x plus 8. Okay? So between 5 and 125 as the basis of your exponential inequality, we will follow 5. Okay? Or let us first identify the base. So 5 is copy. Then we have 125 is equal to, so 125 is equal to 5 cubed. Okay? Are we clear in this? 125 equals to 5 cubed. Then copy the exponent, x plus 8. Then copy, we have 5 raised to x is greater than, simplify, we have x plus 8. So if you can see, the bases are greater than 1, or we have b is greater than 1. So the symbol will be retained. Okay? Symbol is retained. So copy the exponents. We have x. Then we have 3 times the quantity of x plus 8. Are we clear? Then we have x. 3 times x is 3x. 3 times 8 is, we have 24. Okay? So simplifying, we have, okay, I will copy. Copying, we have 3x plus 24. Okay, simplifying, we have 3x minus x using the subtraction property of inequality. So we have minus x on the other side, therefore we have to minus x on the other side. So we have 3x minus x. Then to eliminate 24 on the other side, we have to subtract 24. Because we subtracted 24 in here, we should subtract 24 on the other side. So we have minus 24 on the other side. Or if you can see, positive x is transferred, it will become negative x. Positive 24 is transferred, we have negative 24. Simplifying, we have 3x minus x is 2x. Then we have negative 24. Okay? Then dividing both sides by 2. We will get x, then negative 24 divided by 2 is negative 12. Or writing it the proper way, we have x, the opening, and it points on x. We have negative 12 in here. So we have negative 12 is greater than x, or it can be x is less than negative 12. Okay, writing it using your set builder notation, we have x is an element of real number such that x is less than negative 12. So that's it. So that is how to solve your exponential inequalities. So always identify the basis of your exponential expression on both sides and decide whether the symbol or the sign of your inequality will be reversed or will be retained. So thank you, and please subscribe to our channel. Stay safe.